Hello guys, in the previous lesson we created the mode of the nonlinear system identification equation in terms of the this form x dot equals to the minus a times x squared plus b times u with a specific initial condition. Okay, and so we have obtained the E1 dot, which means that if we properly decrease or minimize this E1 value, and so we can obtain the proper values or the closest values of the a and b function in here. Okay, and so in this lesson we will create the stability rule. Okay, and so in order to stabilize or to minimize the RE1 value, we should properly select the specific energy function. Okay, and so let the energy function be the V is equal to 1 divided by 2. This coming from we have take a derivative of the V or the energy function in here, and so this is square form, and then if we take the derivative of these terms, and 2 is the right hand side of this equation, and so this express the 2 times 1 divided by 2. This is a proper form or the easiest form to obtain the proper values of the R function. Okay, this is a simplification process. And so we do not use this 1 divided by 2, but it's perfect in here. Okay, and so the R energy function should be included with the E1 square, because this is a proper form or the positive definite matrix or the scalar value in here, and so if always positive, and then we can express or minimize our function body. Okay, and so also we should give the 1 divided by gamma value times a estimated square. Okay, and so plus we have the another term in here, 1 divided by gamma value times b estimated form square should be included in here. Okay, because if we have these two parameters, and so a estimated is equal to a hat minus a, and so this goes to the 0, and then we will have obtained the closest values of the real a in here. Okay, and so the taking derivative gives us in here to V dot is equal to the E1 times E1 dot plus 1 divided by gamma value times a estimated value times a estimated hat plus 1 divided by gamma value times b estimated times b hat dot. Okay, and so we don't have the dynamics of the a estimated dot in here, but we can obtain by using this formula, because if we have this kind of information in here, and so we drive the whole system goes to goes to the 0, or the V dot goes to 0, and as well as the V also should be 0. And so there are two conditions in here, like this one, to minimize our function in here, and so we should be always greater than the 0 value, and V dot should be always smaller and equal than the 0 value. Okay, these are the condition to minimize the R function. Okay, and so also we have the E1 dot value from the previous slides. Okay, and so if we have this kind of information, reorganizing the whole forms in here, like this one, reorganizing form gives us to what I can select the red value in here like this one, okay, and so V dot is equal to the what, E1 times minus AM E1. It's a stabilization term to what, to goes to zero of all the dynamics in here, and so plus A hat or estimated value in here times X square minus B estimated value U, okay, and also we should add the 1 divided by gamma value in here, A estimated value, A estimated dot, plus 1 divided by gamma value, B estimated times B estimated dot, okay. And so if you reorganize whole the equation with the specific form of the what, the form of the coming from the what, the A estimated dot and B estimated dot should be obtainable coming from this form, and so we will have this information in here. Firstly, AM minus AM times E1 square. AM is always positive and we have a negative term in here like this one, and so E1 square always positive, and so this always negative, okay. And also we have the A estimated value times in here like this one, E1 X square coming from this term and this term, and also we have the plus 1 divided by gamma value times A estimated dot, okay. And also we have the B estimated value in here like this one. B estimated value is equal to the what, the B estimated coming from these things, and so minus E1 times U plus 1 divided by gamma value times B estimated dot, okay. And so this is always negative, okay, negative, and so these terms also expressed by the selecting the what, the A estimated dot and B estimated dot value, okay. And so if the A estimated dot is equal to this term, and so we have the zero value in here, and so this should be equal to 0 and this should be equal to 0, okay. These are the terms to what, to obtain the proper values or the globally stable values on the estimator dynamics, okay. And so A estimated dot should be selected to what, the minus gamma value and times E1 times X square, and also B estimated value in here in gamma times E1 times U. If we select these terms and or put this equation into the what, into the V dot equation, and so we have the zero value in here and zero value in here, okay. These are the estimation rule or estimator model of our dynamics, but we have only the what, the A hat value and B hat value, okay. And so if the A hat and B hat is the only thing to set or change in time in our microprocessors or the computers, we should transmit or shape this A estimated dot and B estimated dot into the what, A hat dot and B hat dot. Remember that we have the formula for the A estimated value, A hat minus A, and so if we're taking derivative in here like this one, A hat and A dot, and A should be constant in here, or we assume that it's constant, and so this should be 0. also B estimated value dot is equal to the what? B hat minus B dot, and so B estimated dot value should also be equal to the B hat value. And so in the final form we have a hat dot value is equal to the what? Minus gamma times E1 times X square. Okay, and B hat value is equal to the what? B hat value gamma times E1 times U. These are the rules of the what of our system to estimate the proper values of the what of our system A and B, especially in the nonlinear system design. And so in the next lesson we will create a proper controller form to what? To our system, because if we want to drive the system to any point or the reference point, we should also create the controller in here to select the what? To select the U value in here. Okay, but the selection of U value does not change the results of the B hat dot. Okay, because this is an arbitrary number or the outside number, and so if we select the reference or we design the selective reference form or reference ranking form in here, and so we will have this form estimator models in the two ways. We can control our system. Also we obtain the what, the A and B real values. Okay, in the next lesson we will create the controller form related to what? Related to these things.